This is a short story about how the miracle of one life starting could provide the miracle needed to save another life. As soon as an embryo is created, so are stem cells. These precious cells form the beginnings of all the other cells and tissues in the human body. As the embryo develops into a baby, new cells continue to be produced and circulate throughout the baby's blood system. The baby is connected to its mother by the umbilical cord and the placenta. These deliver all the food and oxygen from the mother to the baby.
Cord blood collection is relatively old now when you consider that the first application of cord blood was in 1939 as a blood transfusion. But I would not say it was until the last 5 to 10 years that people really started to take a big interest in collecting cord blood, when it really started to be proven as a therapy for certain diseases. So right now in the UK we're collecting approximately 0.1% of the available cord blood in this country, which is one of the lowest in Europe. When you consider that, for example, in Greece it currently stands at 18.5% of the national population. So I think that we need to have more awareness, and people need to have more understanding that cord blood, which is normally thrown away, actually has a fantastic value.
And so the baby is born. It is separated from its mother and begins its life.
Unfortunately, the umbilical cord blood and placenta generally get incinerated and thrown away. And this is a great waste, in my view, because the cord, the placenta and the cord blood can be of use not just for transplant but for great research for our world.
What if these products are not simply thrown away? Left in the cord is approximately 75 to 150 millilitres of cord blood. This blood still contains many millions of stem cells. We could collect this blood into sterile bags and, instead of wasting it, use it in different life-saving and life-changing ways. We can use the blood in varied research programs taking place in specialist laboratories. We are able to harvest the stem cells. These primitive cells can be cultured in the lab and encouraged to grow into different types of cells and tissue, such as liver, brain and pancreatic tissues. This gives us endless options to use tissue models to study drugs and diseases and work towards new treatments and transplants. Bioreactors like this can be used to grow tissue of the nervous system. With this, we can develop models of the brain to understand diseases like stroke and Alzheimer's. We can also use these models to test new drugs. Here you can see nerve tissues developing in a bioreactor. Larger bioreactors like this can be used to grow large blocks of tissues such as liver. This also speeds up the growth of liver. Here we can see on day 1 the stem cells seeded to a special scaffold, but after only 5 days the cells start to develop into blocks of liver.
Eva was a year old yesterday. So she was born and she was a happy-go-lucky wee girl for what we thought was the first 6 months of her life. And then we sort of noticed a wee bit of a difference in her form. She was not as happy and not as smiley and things like that. So we took her along to her local GP, and he said that she had a chest infection and gave her some antibiotics, which we thought was going to clear it up. But as the next 2 and 3 and 4 months passed, she just kept getting worse and worse. At the end, she was virtually lifeless. So we were whisked off very quickly in an ambulance to the Royal, and in we went to the Royal, and she was put on a ventilator basically right away that Thursday. And she stayed in a ventilator for about, I think from recall, about 11 or 12 days until they got the chest infection sorted with some very high-tech drugs. But it was during this 11 or 12 day period in the Royal that they diagnosed the fact that she had the severe combined immune deficiency.
Right now, about 85 diseases are treatable or supportable with umbilical cord blood transplants. Sometimes this is for very serious diseases and sometimes for less serious. In the case of more serious diseases, you might have to replace the entire bone marrow system of the child, such as in leukemia, and in other cases it's used really as a support system, such as in the treatment of type 1 diabetes.
The best transplant they thought for Eva would be a cord blood transplant. So then as soon as the cord blood arrived, then they got her chemotherapy treatment protocol sorted out, and then she started that then on Monday the 4th of February. So that was 8 days of that, and then she had a rest day yesterday, which was her birthday, and then it was on with the transplant then this morning.
At the moment there are very few private cord blood storage banks and even fewer public facilities. This means that this amazing resource is just being thrown away time after time on labour wards throughout the country. Today, around 85 diseases can already be treated or supported with cord blood, making it the world's most successful stem cell source.
There is a great ethical debate at this time right across the world with the different types of stem cells available. Some people are totally against the use of embryonic stem cells for religious or moral reasons, and others support it. With umbilical cord blood there are no such ethical controversies because every major religion actually supports the use of umbilical cord blood for transplantation and for research.
With over 130 million children born every year, cord blood remains the best and largest source of stem cells on the planet, easy to collect and with great promise for the future.